So my name indeed is Vincent Lussenburg, Technical Product Manager for Backtrace. I've been with Backtrace for 2.5 years now, and did a lot of work in the gaming vertical as well as like mobile. And this is not the first time that I've done a webinar like this. I think it's my third time specifically about mobile apps. And what I really like to do is look at a lot of reports on what movements have been in the mobile market, and talk about what has changed, what's different, what's the same, and how does Backtrace help you in the current market. And that is the focus of this webinar, obviously, how to build top-rated mobile apps and cut your error resolution in half. I'm going to talk about why having top-rated mobile apps is something to strive for to begin with. Let's see. Oh, interesting. I apparently left the poll up, so you guys already responded to the poll. It just popped up in my face, so thanks for doing that. It was supposed to be later in the presentation, but now we have the results already, so feel free to respond to that. I have a slide for that later. Yeah, let me go ahead and get started. What's our agenda? What are we going to talk about? We're going to understand the cause and the impact of bad app reviews and see why reviews are something to keep track of. I mean, it's kind of obvious that you do, but we'll go over some of the research in the market. Second, we're going to talk about how to cut your error resolution time in half. And the third point, of course, I'm going to demo how to do that with Backtrace specifically. And at the end of the session, what we'll do is basically a Q&A, answer any questions that you guys might have, either pre-shared. So feel free at any time to leave your question in the chat or in Q&A of Zoom, like Susie said. We'll respond to that. Cool. So let's talk about understanding the cause and the impact of bad app reviews first. So I like to start with actually plugging Data AI, because they do very, very interesting reports every year on what's been going on, what's been happening in the mobile market. And so I really, the URLs to the bottom of the slide there, I really recommend, if you're in app development, to check out the reports. It's just incredibly interesting what they all write about. But at a glance, what I found interesting to talk about is you see that there's a growth in app downloads, just of 5%. But you see that App Store spend is going up quite a bit. The daily time spent per user is going up a lot, and that's 2021, of course, was a lot of pandemic time still, but partially less pandemic time as well. So it's still interesting that daily time spent per user is going up. What we see as well is that there's a lot of spending that's going towards the mobile apps, and you see that 60% of the expenditures is in games, which still means that there's 40% just in regular apps that money is being spent, either through ads, and what they compare it to basically 41 largest country ranked global economy. So that's fun, I think, to think about how much revenue generated by that. And the number of apps that are available that have over $100 million spend, which is this magic number that a lot of these mobile companies go for, has grown 20% year over year as well. So that's really interesting. So the takeaway here is that not only people are spending more time in apps, doing more things in apps. You see, for example, that usage of bank websites is going down, but it's still going down. But the usage of their mobile apps is going up. But the second part as well is for you who joined or with companies that are dependent on revenue from your apps. You're in a good ecosystem, because it's still growing a lot. 20% year over year growth. That's a lot. So again, all this data comes from Data AI. You can go to that URL to check out their report. It's not the only thing that I read. So what I'm going to focus on, and you see that on the top left, that ratings run the show. So I've seen previous years as well, but this year's again, that Apple and Google have both invested in making sure that they get as many ratings and high quality ratings as possible. So I have 2 quotes for you. First one from App Figures. Thanks to additions from both Apple and Google that enable developers to easily ask their users to provide a rating, I only see this total growing faster. Stores relying on more for discovery and consumers relying on it more as a measure of popularity. If you have an app or game out there, you'll need more ratings to stay competitive. So that's a large focus there, and not just like more ratings, but high quality ratings or 5-star ratings, 4-star ratings, and stuff like that as well. Again, from App Figures. Another quote from Apptentive. New App Store ratings have become the most critical signal for rankings and will continue to lead in importance in 2022. This means that to rank higher, apps need more new ratings, not download, not revenues, just ratings. Again, if you look at the research of both App Figures and Apptentive, they focus a lot on looking, okay, how do the algorithms in the app stores work? Ratings are of paramount importance. It's actually interesting that after search engine optimization, there's App Store optimization as a legitimate sort of business right now, because what you of course want to make sure is when someone puts in a keyword that your app comes up. But turns out it's not just about the keywords. Ratings are, incredibly important. Cool. So why should you care about these ratings? Because it's kind of obvious. It's nice to have a 4 or 5 star app, but what's the opportunity cost of having 1 star less? So this is from Apptentive. Again, they've been running this poll for a number of years now, since 2019, I want to say, or something like that. And every time I read this, I see very similar numbers. There's a lot of people that are not even willing to install an app that has 1 or 2 stars, and you see the ratings on the right-hand side here. How large of a difference that is. And if we look at this quote, when we asked, consumers were clear that the lower the star rating, the less likely they'd be to download the app. The opportunity cost of a star is huge. Moving a 3-star app to 4 stars, for example, can lead to an 89% increase in conversion. So you very clearly can see 4-star or 5 stars. That's where you need to be. So it is important. Why should you care? To adopt new users. To get your new users exposed to your app, it is essential that you have high app ratings. And that's not just about that. Companies like Apptentive and App Figures, of course, are in the business of making sure to collect and to stimulate users to leave that feedback. But from a Backtrace and Sauce Labs perspective, I'm going to look at that from a different angle as well. Because I like to look at what drives bad reviews. So it's not just about engaging with your customers and getting their feedback. Their feedback can actually be very damaging to your brand. So I have 2 overviews here. One from Apptentive, one from a master student who did a study. It's a little bit older, 2016, where the one to the left is actually a 2022 one. It's based on mobile app usage from last year. Let's see. So what we see and what I highlighted in red is the things that are related to problems in your apps. So on the left-hand side, you see that every time, which you can already associate with a complaint, is heavily correlated with negative reviews. Please fix, doesn't work, keeps crashing, try again, stop working, etc., etc. So you see that those kinds of feedback that customers leave are usually associated with a bad review, which also is a showcase of the fact that you want to make sure that a user isn't frustrated by a problem by knowing that the user has a problem early on and fixing it as quickly as possible. In addition, of course, to providing a good support channel, which is the reason that I started that poll on the error reporting there. The table on the right-hand side is older research, but it points at the same direction. So what you see is that it's a little hard to interpret this table. So let me do that for you guys. What it comes down to is that the problems like functional errors, app crashing, network problems aren't like the highest drivers of bad reviews. It's mainly if it's like privacy or ethical or feature removal that really stimulates users to leave a hate review. But they are like sort of the next leading cause of bad reviews. The problem, that you have with not just like network problems, apps crashing, but like resource heavy as well, which Backtrace can play a role of monitoring that as well. Cool. Let's keep going. Well, I have a slide for the poll question. Apparently, in my limited knowledge of Zoom webinars, I already had the poll open. So I see that a number of you guys participated. I believe it is still open, so you can keep giving feedback there. But my question was, for the different people that joined, how do you guys detect issues today? So the responses that I've gotten is that the vast majority of you guys are already using error monitoring and crash reporting, which is great because that's the angle that I'm talking about as well. I would say second place, we see that people do that via different channels. So think of support tickets, email, in-app chat, so that customers can report that they have problems. So the difference between those two is error monitoring and crash reporting does it for you automatically. It doesn't have impact on your user. User doesn't have to do anything. If a user has to manually connect to like a chat or a support ticket or something like that, the onus is on them to provide a lot of the information and things like that. So that's different. A third, we see App Store reviews. That's one of the things that I focused on in the piece about the research just now. Generally, if you are reliant on your App Store reviews to get customer feedback, your feedback cycle usually is pretty long. And generally, when people leave a review and they are unhappy, they have a problem, they are already like pretty annoyed at that stage. Then I see a couple of good people as well that get customer feedback via social media, and some people also just don't know, like it just comes in via the grapevine. So thanks very much for responding to that. Okay, I guess that I had to click share results, and which I did now. So I'll just leave that open for a second. I'll stop sharing. Cool. Let's keep going. Second part of the agenda. I'm going to talk how to cut your error resolution time in half. I think in the previous part, I made a case on why app reviews are important. They drive adoption by new users. So what is really important that to prevent those bad reviews from impacting how happy your customers are with your product, it's really important to cut that resolution time. And I'm going to show you, like using Backtrace, how you can cut it in half as a reporting. So to preface and set the stage for my demo, I'm going to talk quickly about error monitoring, crash reporting in production and across the software delivery lifecycle. Because Backtrace is part of Sauce Labs, and I like to talk about not just like we're focusing really in detecting problems in production, but there is more than production, and what happens in production influences your development and integration as well. So what you see here is the entire software delivery lifecycle and what kind of forms of testing that you have around that. Of course, Sauce Labs being a company that's really focused on testing and delivering high quality apps. During development and integration, it is really important that you do as much tests as possible to make sure that you find the problems that would be embarrassing in production. But the way that the market works right now is you do want to push features out to production really quickly. So it's not key to sort of test to death, but actually to push things out into production and be in a situation that you can see whatever is happening in production and use that to very quickly iterate and improve things. And that's where Backtrace comes in, because problems are going to happen in production, right? No matter how much like low-code automation, automated tests you do, live tests you do, you're going to have problems, either doing beta test or actually in production. And the key is to respond to that really quickly. And I don't know if you guys can relate with that, but like sometimes the way that I bond most to an app or a product or something like that, not that it's absolutely void of problems, but if I have a problem, that it gets fixed really quickly, either by having stellar support or just having like that turnaround being really quickly. Because sometimes I imagine a lot of you are like me, I'm too lazy to like really create a support ticket or something like that. So it's important that it fixes itself automatically. And that's where Sauce Labs and Backtrace play a large role. Because if you monitor whatever is happening in production, the things that are affecting your users, such as crashes, but also like app hangs and like things like that, you can use that, apply those insights, and feed that into your next development iteration. Cool. So our customers have seen when they integrated Backtrace in their apps and games that are running in production that mean time to detection and mean time to resolution are greatly reduced. Mean time to detection by over 90%. So if you guys remember the poll, you can think about the feedback loop of the different types of crash reporting. And the majority of you guys are using error monitoring and crash reporting. There's a slight difference between the two. Error monitoring tends to only capture like sort of the soft problems. Like your app is still working, but there's some kind of functional problem, like I can't update my delivery address or something like that. Where crash reporting also works when your app completely dies. And generally what we see with a lot of companies is that your errors live in one place and your crashes live in another place. Maybe your iOS and Android crashes are even at different places, maybe in the same solution, but in different buckets. So all of that impacts your mean time to detection. The moment that you know the fact that you have a problem, the mean time to resolution more is related to making sure that the developer has all the information to actually fix the problem and push it out to production. So I'm going to talk about, excuse me, how Backtrace helps with that. So how are companies doing this today, trying to reduce that mean time to detection and mean time to resolution? Like I mentioned, the data capture in various unconnected stores. So issue trackers, Excel databases that get that information from Twitter and maybe your error monitoring as well, and maybe from your support channel, but they are usually unconnected. So it's hard to see if the person that's complaining on Twitter has the same problem that you detected automatically. So that involves manually triaging, seeing how important it is, grouping, prioritizing the issues as they come in, which is labor intensive. To do something that's called symbolication, and which basically what it comes down to, when an app crashes, you don't have the same quality of crash report that's easy to read for humans. You actually have to do processing with debug symbols that are generated when the app is built to make them human readable, which is also labor intensive if you have to do that manually. And in an attempt to reduce the mean time to resolution, a lot of companies try to be able to contact customers directly to ask additional details. So that can be in-app messaging, which is really like pretty popular right now, so that you don't have to email and tickets, but a lot of companies still do it through tickets and email, which can be really frustrating and slow. Cool. So that finishes the part about the how and like sort of the why of cutting your error resolution time in half. I'd really like to show you a demo of how some of that is possible using Backtrace, using the XDKs that we have. So what I'm going to show you first is focus on that reducing the mean time to detection by 90%, right? So capturing the errors, hangs, and crashes. So first of all, we're going to look at the low-code open source SDKs that we have available. We're going to take a look at how we can collect the fact that and these different types of errors, handled exceptions, unhandled exceptions, etc., occurred, and that the relevant context is being captured, and that how it's scalable. So like whatever your apps are sending the crashes to, like basically the Backtrace endpoints, are capable of handling millions of reports a day. So let's go ahead and take a look. So the first part of my demo is going to be a video because, you know, the rest of the demos will be actually against a live system, but integrating an app live, that's trickier. So I actually pre-recorded that. So we're going to take just a quick look to get a feeling on how the SDKs for Backtrace look by integrating it into an app. So this is just a demo app. What we need to do is simply create a pod file. A lot of app developers use pods, Cocoa pods, to add functionality to their games. So in this case, you can just add that. You then install Cocoa Pods, the iOS framework, or make sure that you have the latest version, and then you do a pod install. And magic happens behind the scenes that makes sure that a workspace is generated. And then you can basically open up that workspace afterwards, which I'm about to do here. And what's different now is once that project opens now, it also will build the Cocoa Pods for you. So that's basically the functionality, the code that you need to do that error reporting. So what I did here is I pasted initialization logic, which is basically copy-pasted from our project settings in your Backtrace universe. If you have a Backtrace instance, I'm going to show that to you guys later. So this is just a copy-paste, it's pre-generated. That's all you need to do, initialize it. I'm going to add explicit catching. By just importing it, it captures like sort of soft errors already. Well, that one, let me pause that. That one a little fast. So basically what this will do is when the app crashes, it just basically sends the crash to a Backtrace endpoint. And if there are soft errors, like the errors that I was showing here, so catching some functions, you can explicitly do that and add some metadata to that. So if I then quickly go back to, so you see that, like you can add custom attachments or specific attributes. So if I go back to here, like I'm talking about the iOS low-code open source SDK, and so we see that you can explicitly capture handle exceptions, and that crashes are captured automatically. So that was the part for iOS. Again, 30,000 foot overview really quick. So let's switch to Android. We have a separate SDK for Android. In this case, all you need to do is in your Gradle, import an extra library, making sure that the minimum SDK version is 21. So it's just a Gradle dependency, Maven dependency. This video is slightly older, so I think 3.10 is not the latest version anymore, so make sure that you grab the latest version. So it's going to download the SDK on the background here. Again, both these SDKs are open source, so you can see the source code as well, see what they're doing, how they're doing it, modify it if you need to, create pull requests. And this is again like a little demo app, so I'm going to import the Backtrace client, which came from that dependency that we just downloaded. And this is again from the project settings page, so you can just like directly copy paste the configuration and then enable the Backtrace integration. So in this case, there are some reasonable defaults with the background exception handler that's also enabled. So that means like any background thread or main thread throws an error, it's going to be reported to Backtrace automatically. Just like for iOS, you can explicitly capture errors as well. So if I have try catch here and I want to add specific metadata for this arithmetic exception, there it is, then I can always pass that information to the Backtrace client directly. Now, this is not the only way to do it explicitly because it's, of course, annoying to write try catches. So you can do that in a cross-cutting way as well with callbacks. But this is just an example of, hey, if I want to add metadata on the fly about this crash, I want to add a screenshot, log file, in this case for a webinar, like add a custom attribute. That is all possible and really easy to add, and that's important in order to triage your errors later on. So cool. App permission to connect to the internet, of course, is important as well. We're just going to run this app. This app contains a hang, a crash, and an error. So I do want to like underline that as well. So it's not only the hard crashes that Backtrace captured, something like a hang as well. So as you see now, clicking the next button doesn't do anything because the app hangs, and we have the logging. So it does say in here that the app hangs, but this is something that's communicated to Backtrace on the background as well. You see that it doesn't impact the user, and if it crashes, that's sent to Backtrace as well. So that's really all that there's to it. So if I switch back to the slide, what we've seen is the open source SDK for Android and iOS, and how to integrate them, how to add the fact that the crashes are captured and add the relevant context. And what I haven't really shown you, and you'll have to take my word for, is if you run this on thousands of clients, that Backtrace is able to handle that. So we, for example, our largest customers are AAA game studios that send up to 200 million error reports a day around launch time. So we are very focused and built for scalability. So all of this is focused on that you hear about your crashes in an automated way and really fast compared to the other channels of collecting it. So now that you've instrumented your app to send that information to Backtrace, we want to help you improve your signal to noise ratio, because getting like drinking from the fire hose of crash reports is great, but that doesn't mean that you actually understand better what's going on, right? So how does Backtrace make prioritization a painless task? So we're going to look at automatic deduplication. We're going to look at multiple platforms in one overview, the bidirectional workflow integrations with Jira and Asana, and different metrics for prioritization that I partially already mentioned. So the deduplication, problem-free users and sessions, grouping by device, version, platform, and more, flame graph, and zooming in on individual sessions. So I'll show that to you in the demo. Again, the aggregation of these million reports is done with minimal lag. So that means like the moment that you're getting like a lot of error reports because something is down with your app, it's not that we can't handle the load and that you only see what happened like an hour ago or something like that. That's all focused on that. Just see how I'm doing on time. Okay, cool. So here we are at Backtrace. And luckily I'm not logged out. That's always the demo effect that I'm afraid of. So what we see here is an example project that I have for this webinar, and it has, so first of all, let's focus on these multiple platforms, and I'll quickly do that by switching to the Explore view. I'm going to explain this a little bit better, but I do want to start by highlighting that the Android and the iOS crashes all end up in one project, and that's very different from all of the some of the other crash reporting solutions that we're at. So that's the multiple platforms in one overview. Let's talk about that automatic deduplication. So what we see is that we have 5,300 errors, but I only have like 5 different groups. That is Backtrace's automatic deduplication, which is largely based on call stack and a couple of other metrics. But long story short is that if you have hundreds and thousands of users that are having problems, you don't have to manually like look at these things and see which ones are the same. Like we see if it's the same root cause, we already do the deduplication for you. There's a lot of error and crash reporting solutions just like Backtrace that do that. We have best in class in the deduplication. We are known for doing the deduplication as one of the best ones, and not just for mobile. And we do it for like, PlayStation and Switch and stuff like that as well. So we have a very broad and powerful deduplication that we've worked with for years. So that's the deduplication across tens of thousands of devices. Let's talk about the workflow integrations. So one of the reasons that it's really important that the data is being captured is really important, but you need to get it to your developers. So the moment that a ticket is created, that an error is detected, Backtrace can automatically create a ticket for you. So what we create in Jira is a rich overview of what's going on, gets information about which versions are affected and stuff like that, is highly customizable as well. I can edit these tickets. I can assign this to a person. If I assign it to someone in Backtrace, it gets assigned to that person in Jira as well. And if I change the status, the same thing applies. What I can do as well is the moment, and I can do this in Jira and I can do it in Backtrace. I'll do it in Backtrace now. I can say, hey, maybe I suspect that this problem is related to something that happened with like maybe a backend service that's fixed now. And I can then say, it's like, hey, I think that it's fixed, or I fixed it in a specific version. So I can basically tell Backtrace, well, I think we're done with this. What Backtrace then will do is automatic regression detection. So the moment that Backtrace sees it for a higher version, or sees it like, again after a day or something like that, it can reopen that ticket, both in Backtrace and in Jira. So going back to this, it's bi-directional, and that makes it really powerful to get an overview of what's going on in your organization. Let's talk a little bit more in detail about metrics for prioritization. So what is really important, if I look at this overview and I want to know if I have a problem or not, is the ability to see trends. So if I switch to my overview page, I get an overview of how many error-free users I have. So this is basically users that are not getting like any problems at all, or application launches. This is a really important metric that tells me something about the health of my application without looking at these absolute numbers of 7,500 errors, because I don't have the context. We see the errors over time as well by version. So I can see which of my versions are the most problematic. It looks like this 2.10 version has some kind of problem that the other ones don't have. And I can also see the error-free application launches. In this case, it crashed to 0 because there were 0 application launches, so that makes sense. But if there's something like a disturbance that happened to your app, you would be able to see the trend on that. What's also really important is the ability to see your user adoption. So what we have in the releases overview is the ability to see all the versions of the apps that you have out there, especially for mobile app development. You have to deal with multiple versions out there. So you can exactly see what your user adoption is for every version. So we track those sessions. And you can also see for those versions what your error-free rate is. So I can very clearly see, again, for this 2.10 version, that there's some kind of problem there, because the error-free users rate is a lot lower than for the rest of the versions. So realize, just by having that information, how much better I can triage now, right? Because now I have also in percentages the context of how many users are affected. And that, drives my priority a lot. So we talked about deduplication. We talked now about the percentage and amount of affected versus problem-free users and sessions. Let's talk about the grouping by device, version, platform, and more. This is where the Explore view is made for. The moment that you want to look at your data in various different ways. So I can, for example, what I like to do, let's just do it in the sake of time by version, because we already know that there's a version with a problem. We clearly see that Backtrace also knows how many launches there were for that specific version. So I see for 3.02, I had 260 unique sessions, and for this 210, I had, I should say 260 problematic sessions, and this one had just a lot more. So by percentage, I know that 85% of my users are affected with problems here. I can then pull in more data that Backtrace captures. Like, for example, I might be interested if it's related to Android versus iOS. I can see that that's similar across the board. So I can immediately say, okay, well, that's not the reason. What I can pull in, for example, is the process age. And my Zoom window is in front of what I want to click. Bin. What I can see then is for this problematic version, all my errors happen in the beginning. So because Backtrace captures all that metadata for each and every single error report, I know that for the vast majority of my error reports across these thousands of errors, it happens in the beginning. So that tells me the problem is in the beginning of the app. I can pull in information as well. In this case, I'll do host name. And what I see here is that there is like, I don't know, 10 10, 12 host names that specifically have a lot more problems than the rest. And if I compare that to my other versions, like all my users like sort of have 2 errors and that's it. So there's 2 things that I want to mention here. So first of all, notice that the host name is obfuscated. So it does relate to a unique device, but I don't see like Vincent's iPhone or Susie's iPhone or something like that. So that's something that through our SDK that you can do. So that means that every developer can look at this, and not just a lead developer that is allowed to handle PII data. We can scrub that. And the second part is that everyone can clearly see this affects a specific group of my users. I can even pull in session information. Let's see, how am I doing on time? All right. And that leads me to zoom on individual sessions. I'll skip the flame graph for now in the interest of time. So we've looked at Backtrace and being able to show you vast amounts of data. But what if I want to zoom in on an individual person? Maybe that's a whale, or someone that spends a lot of money in my app, or whatever. Maybe it's an influencer, although that's a little bit more applicable to games. So I can filter onto an individual session, and then I can click on list. And what I then can see for this specific user, and I can pull in other attributes like, what's interesting here, maybe I should do process age, or like, let's just do version, keep it simple. But I can pull in all kinds of information on these reports, and I can see what was that journey of my user, like when did they start using my app? What kind of actions did they try to complete before they got to like basically that final crash that ended their application. So we have the ability to see vast amount of data, but like through a list view we can follow an individual user on what they did as well. So you have both of those resolutions. You can zoom all the way in and zoom all the way out. So that's zooming on the individual sessions. Again, the aggregation of millions of reports with minimal lag. I can't really show you that in a demo, but it is something that our technology is purposely built for. Our database is focused on handling vast amounts of data. So there's nothing that you can throw at us that will make it lag. Of course there is something, but the AAA studios that do like 200 million error reports in a 48-hour period, like we handle that, no problem. Cool. So then we have one more piece that I would like to demo, and that is related to reducing your mean time to resolution, right? So what we've seen now is, okay, we detect these errors a hell of a lot faster. The second part that we've seen is that we can prioritize based on that context data and stuff like that. That shows us how much users are affected, if how many users are seeing this error, which is important. And then if we selected, okay, this is an issue that I actually want to fix because it's impacting a lot of users, or it's annoying, or it's a hard crash, or something like that. What the next step is actually giving your developers the information to resolve it. So how do we do that? Well, first of all, the automatic collection of relevant error and crash information. That's the same as the mean time to detection, obviously, except what the underlying or the point here is that the error and crash information is collected automatically. So you don't have to contact your user to get additional information, like what iPhone were you on, what was your iOS version, what level were you playing, or which screen were you on, something like that. Leads to the rich debugging metadata, attachments that you can have, deobfuscation if you're using a ProGuard or something like that to protect your intellectual property. Backtrace can unwind that for you. The symbolication that I talked about, if you have a hard crash, you don't have to download the mini dump and find that stuff that Backtrace can do for you, so that even for crashes you have a human readable call stack. And device metadata that I talked about. I'll talk about breadcrumbs as well. I'll show you those, and these are the actions that the user and the system did, or those that occurred prior to the issue. So it's your breadcrumb trail up to that. Source code integration and the automatic scrubbing of personally identifiable information that I already touched upon really quickly. So what we'll quickly do is I'll clear this filter here. So we'll go to a debug view. So this shows me the individual error. So far we've seen like these normalized overview. This is the individual error, right? So what we want to see with this individual error is that the relevant error and crash information was collected, obviously. and that it was symbolicated in a way that I can read what was going on. So you see for some things, for the sake of a demo, there is no symbols available, so you do not see what the actual problem was, like what function was being called. If you have the symbols available, you have a more complete call stack and information exactly where your problem occurred. There's a lot of metadata that's being captured here, the error message. There is attachments that could be included. Let's move forward to, for example, this is a Java example where that's the divide by zero that we saw earlier, so that we get information on all the threads that were active here. Attachments as well. Let's see if I don't think there's a screenshot on this one, but you could attach one. But we'll take a look at breadcrumbs. So what we see in breadcrumbs is that Backtrace allows you to add your own breadcrumb configuration, in the sense of, like, for example, if I'm like going to a certain, do a certain action, you can say like a user, started a tutorial or something like that. But there's system information that is being captured as well. So the moment that there is a memory problem, that system dialogues are being closed, that the app by itself is being paused, all that information is made available, in addition to a lot of like environment variable information that scrubbed as well, and other details about the stack trace. Right. Let's keep going to another example so I can show off the source code integration. Let's find, this is probably a good example, where you can simply click on basically your faulting thread, and it will open up the, it connects to Git and Perforce and stuff like that, and is able to show you where the error occurred. In this case, it's not really that complicated to find out what the problem was. That's what we just added in the integration. One of the things that I like to add here is that a lot of companies don't like third-party companies like Backtrace to have your source code. Know that the source code service can contact directly to your infrastructure. So we don't have to have access to your source code. It doesn't even have to go through Backtrace. But through like a little service that you can install in your infrastructure, we can showcase that to you like within the Backtrace UI. So it's important to highlight because even the companies that are very conscious about that can make sure that it's possible for them. Cool. Let's switch back here. So I showed you some information about the attachments that could be added. We saw that stacks are de-obfuscated and symbolicated. We saw attributes, device metadata, environment variables on Android and stuff like that. Gives me very rich debugging information for a developer to not have to go back to that customer and ask for additional information. We looked at breadcrumbs, so the actions that the user might have done and what the system, what happens within the system. We saw the source code integration with Perforce and Git and more. And we saw that personally identifiable information was scrubbed, so there's no credit card, social security, user information that's here because it's cleaned for you automatically. Cool. So I'd like to recap. Let's look at the time. Looks like I'm right on time here. So to recap, I would say that Backtrace is best-in-class error and crash reporting for your mobile apps. I'm not saying that Backtrace is the only thing to use. Look at the beginning of the presentation on what's important to get high ratings in the App Store, why it's important and stuff like that. You can achieve that in multiple ways. In no way I'm saying like Backtrace is the only way to roam in a way. But I do think that there is a couple of very compelling value adds in Backtrace that make it really nice to work with versus some of the other integrations that have a longer feedback loop. So the full lifecycle of automated crashes and error capture, the true cross-platform for mobile and not just mobile. So you can import problems from your server side as well. The purpose-built database technology for the analytics workloads on app stability. In other words, we can handle those millions of reports without grinding to a halt, which is really hard to do if you're doing it homegrown or with a system that you get for free or something like that. And it is fully integrated with tools like Slack, Jira, Teams, GitHub, Datadog, so that your data doesn't just live on an island and someone needs to know where it is, but it's fully integrated in your workflow for fully DevOpsified. Cool. So we've talked about the cause and impact of bad reviews, how to cut that error resolution time in half. We saw the demo, and now it's finally time for the moment you've all been waiting for, perhaps, the Q&A.
Fantastic. Thank you so much, Vincent. Appreciate you running us through all of that. I know we've covered a lot of content, a lot of information. We will, again, be sharing this information out with everyone so you can get a closer look at those slides, dig in a little bit more following this. But let's jump in. We do still have a few minutes for questions. And as a reminder to our audience, please do continue to submit questions through the Q&A window. Happy to get into anything that you want to hear more about. Vincent, we do have a question coming through, and this is, I know, something we were talking about as well. We're focused on Backtrace for mobile error and crash reporting, right? And there's some curiosity around whether Backtrace also works for web apps. I mean, does it work for mobile games? Can you talk a little bit more about the scope?
Absolutely, yeah. So it works for web apps as well. So we have JavaScript integration for example. So a language level integration that you can embed in your website, and not just that. So think of any language, programming language out there on the server side. So like C#, Java, Python, Ruby, Go, Rust, etc., etc. We can integrate with all of those different languages. And they can all end up basically at the same place, and like PlayStation, Switch, all the game consoles as well. We can directly source crashes from there as well.
Fantastic, yeah. And sort of along those same lines, and thinking about coverage, right? Where are we testing what devices, which apps? You shared the software delivery, cycle that we think about here at SaaS, and how do we have that comprehensive testing and comprehensive visibility into all of these various quality signals. And obviously Backtrace is a really important part of that bigger picture. Could you talk a little bit more about where should folks start using a tool like Backtrace? Is that development? Is that QA? Sort of where does that fit into the bigger picture?
I can absolutely do that. Let me just quickly share that slide again, because it is really helpful to talk over that, or to use it as a background. So it's a great question. It's a question that I often get. It is important to start Backtrace before you go to production. At least that's the ideal situation. Why is that? Because the problems that you're then seeing in staging and production, you can relate them back to problems that you saw during QA and development, right? So generally, because in development, the way that apps are built and stuff like that, and with some of the things that I talked about, like the symbols and stuff like that, it doesn't really make sense to do crash and error collection in dev, because you don't know if that's actually going to end up in production. It can just be like the little thing that the developer is working on, and they have it open in their Xcode or Android Studio anyway. So there it wouldn't really make that much sense. But so really the moment that you're starting to QA things, so your QA builds should be like enabled in for Backtrace and send errors there. So basically during the integration phase is basically where it comes down to. Yeah.
Thanks for pulling that back up. Definitely helpful to have the visual. There's a lot on there. Question coming in, looking for some comparisons from Igor, asking what are the pros of this tool, Backtrace, compared to something like Firebase Crashlytics? He's asking, you like some of the UX choices made here more than Firebase interface, but as they say, it is hard to beat free. Do you have any comments on that, Vincent?
Yeah, no, absolutely. I mean, there's a lot of engagements that we have with prospects that are moving away from Crashlytics. So I've replaced Crashlytics in my previous roles like a number of times for both apps and game studios. Where it comes down is that Crashlytics supports you decently enough if you're starting with an app. it becomes really hard to manage because your Android crashes live over here, your iOS crashes live over there. So it's really hard to do root cause analysis. It's hard to control basically your retention. That's more or less determined for you in Crashlytics. And making the call stacks human readable is something that doesn't really work that well either. And lastly, I wouldn't be able to say like the most important one, but try integrating Crashlytics in your DevOps workflow, like integrating it well with Jira or Asana or like Slack or something like that. It's not really focused on that. That's not why Google like built it, I feel. So yeah, that's my that would be my short answer to that.
Yeah, definitely some limitations, and the benefit of those integrations is definitely a big one.
Another point is that it's hard to beat free, but Backtrace also has a free tier. So up to 25,000 error reports, and you can control client-side what's being sent to Backtrace. You can do with Backtrace for free, and gives you one user that logs in Backtrace, and that's a developer tier that stays free. So there's another free there.
Great. Yeah, don't have to beat free. There you go. We had a question from one of our attendees, curious about the pinpointing the source or the reason behind crashes. She was asking if there's any way to pinpoint if a crash is happening because of the library used in an app versus because of the app code. Is that something you can speak to, help clarify?
Yeah, absolutely. And it's a question that we often get, especially for apps that are using ad networks or something like that. And there's often hangs in these ad networks. It's actually, funnily enough, the demo step that I skipped in the interest of time. But we have a flame graph that across all of your crashes shows, okay, what are the call stacks that are affected or that are the most brittle. So what it comes down to is we can very easily help you get insight into what are the crashes that are in my app itself, what are the crashes in third-party libraries, by like looking at that flame graph and selecting and then filtering on that. So you can also always say, hey, I see this hang in my ad network library. Let me filter on that. What are my other crashes? Or let me filter it out. I'm not interested in seeing anything of this ad library because I just have to use it. Hope that answers that.
Great. Yes. And if anyone has further questions on that, definitely reach out. We're happy to dig in further, demo more of the flame graph component that we cut for the sake of time today. Glad we got back to it. Vincent, I know you were demoing with us. We were looking at both iOS and Android applications. And a question here from Gregory asking about whether we're recommending combining iOS and Android data versus having that reported separately by platform. Is there any best practice that you could share or elaborate on?
Yeah, I'm going to misquote a meme, like, can we have both? Like, isn't that the meme with the little girl and, So the thing is, sometimes it's really important indeed to focus on the iOS part or the Android part. But there can be very important reasons where you want to combine like the sources of data. So generally, I will readily admit, is if you're going into the weeds of an individual problem, it's going to look slightly different from for Android to iOS, even if you're using a platform independent like library to develop your app, right? But if it's things that are related to which screen am I getting most errors on? Which action that the user is doing is causing problems or not causing problems. It is really powerful to see that across iOS and Android. The moment that in Backtrace you want to say, hey, I'm only responsible for the Android app, I only want to see Android errors and crashes, that's a simple filter that you can enable. So basically what Backtrace does is it gives you the choice instead of having to have it in separate stores. I hope that helped.
Yeah, can't it be both? Yes, that's great to have the option, right? And give everyone the flexibility to choose what they want to see and what's most useful
Right.
for the items that they are looking to test and get data on. We're coming up on the end of the hour, and I think I want to wrap here, Vincent, with question that relates back to our start of this conversation and the title of this webinar itself, right? How to build top-rated mobile apps. And one of our audience members is asking about the diminishing returns for improving ratings, right? To go from that 4-star rating to a 5-star. I don't know if this is a Backtrace specific question or if you might just have personal opinions on it, but do you think it's too costly to pursue those 5 stars or have thoughts on making that leap from 4 to 5?
I can only like sort of give anecdotal experiences or something like that. Personally, my answer, and it has indeed nothing to do with Backtrace, but it depends on your type of app. I think that 4 stars is absolutely fine if your app is from like a brand, like a large bank or something like that, or a retail store. If you're between 4 and 5, that's fine. But it can be important if you're an independent app developer or game developer or something like that. And if someone searches the App Store for like whatever you do, like Brain Puzzle or maybe a budgeting app or something like that, your ratings will influence how high you end up in those lists. Again, that's a little bit less my expertise, but like look at the reports quoted in this webinar. It will tell you a lot more about, where, the diminishing returns start, the returns start diminishing, I should say.
Great. So worth pursuing depending on the space that you're working in. And certainly tools like Backtrace can help make that leap. So I know, Vincent, you wanted to share, you talked briefly about that free tier. We were talking about hard to beat free, and here we go, we don't have to.
Right.
Do you want to speak a little bit to what folks can do from here?
Yeah, absolutely. I mean, first of all, I just want to thank all of you guys for participating. And like I said, at register.backtrace.io, you would have the ability to start a trial. So the trial is a 30-day trial, but it automatically reverts to that free tier. So it does start out as a trial, but it like turns into the free tier. So anyone that wants to do that, and we'll include that in the follow-up as well, would have the ability to test drive Backtrace, and I do reach out with any questions, either to me personally or in the collateral that we'll share after this webinar, and I'll hook you up with the right person. Yeah.
Wonderful. Well, thank you, Vincent, for all of that great content and conversation. And thank you to everyone for attending, for your questions. Really appreciate the participation and engagement here. Before we close out, just a quick note, when you exit the webinar, you will see a brief survey. We would really love to see your feedback there to help us continuously improve and bring you conversations of value in the future. You will also, as Vincent mentioned, we will be sending out that follow-up with some more collateral and of course the recording of today's session, as well as the slides that Vincent was sharing. So stay tuned for that via email. And with that, on behalf of Sauce Labs, thank you all so much for tuning in. I hope you have a wonderful rest of your day.
Thanks, bye.